theorem in here and analyze how we can use that one for our number 57 for such, okay? Let's read it first. Cecilia, go ahead.
Given a polynomial function f of x, its possible rational zeros are p over q, such that p equals the factors of the constant term, and q equals the factors of the lead coefficient.
Thank you. All right, so as quick as that one, for number 57, it says we have to list all, not the actual, all right, all the possible rational zeros for the function, number 57, 2x cubed plus 3x squared minus 8x plus 5. Okay, so once again, we have to find first our p. What are the possible factors of the constant term? Right? 5. So what are the factors of 5? Anyone? 1 and 5. Very good. Plus or minus 1. Plus and minus 5. Are we good? Right, so the factors of 5 can be 1 and itself. Get it? Why? Because, well, basically 5 is a prime number. Good. Okay. Next one. What is our Q? Factors of the lead coefficient. That's 2, right? That's our lead coefficient. What are the possible factors of 2? Very good. Plus or minus 1, plus or minus 2. Once again, because it's prime, its factors are just 1 in itself, right? Okay, good. Okay. Now, with that being said, what are the possible zeros or roots now, right? So, possible roots or zeros will be what? Of the form P over Q, right? So, you divide this by this. Each, right? So, that's, for example, in here, what's that? Plus or minus 1 over 1. Plus or minus 1 over 5, right? So that's basically good. Do the same with 2, right? That means what? 1/2 in here, plus or minus 1/2. And the last one is plus or minus 5/2, right? And again, those are the possible roots, right? So in short, we cannot see any real root that is what? Not in this list, right? For example, 3/2 is not a possible root. We good? Right? 7 is not a possible root. Okay? Because all the possible roots, you can only get something from any of these 8. Again, positive or negative. Are we good? Okay. Next one, we're gonna deal now with what we call a Descartes rule of signs. If you know Rene Descartes, right? Our Cartesian plane, right? The x and y axis, right? It's our Rene Descartes. Before we do that one, let's deal first with what we call the negative numbers raised to a power. We said in here, it just depends on whether the power is odd or even, right? To know the sign, okay? For example, if you have a negative number raised to an even power, just disregard that negative sign and make it positive. Get it? Okay, for example, if we have, say what, negative 2 to the 4th power, what's that gonna be? Just disregard the negative, make it what? 2 to the 4th power, which is basically what? 16. Get it, guys? Once again, any negative number to an even power, remove the negative. Are we good? Get it, guys? Okay. Second, if it's odd, then make it negative. Good. For example, negative 2 to the 7th power is equal to what? Negative 2 to the 7th power, right? Without the parentheses anymore, right? Get it? Okay. And what is that going to be? Negative what? What's this? 2 to the 7th power on your end? What you got, guys? 2 to the 7th power?
128.
128. There we go. Get it? Okay. In short, if the power is odd, sign change. If the power is even, leave it positive or copy. Are we good, guys? Okay. Because we're gonna use that one for what we call Descartes' rule of signs, right? Let's read this one. What do we mean by Descartes' rule of signs? Let's read it first. Civilai, go ahead.
Given a polynomial f of x,
Okay.
the number of
Positive roots.
positive roots
Less than or equal
less
to?
than or equals number of sign change of f(x).
Thank you.
number of negative roots less than or equals to number of sign change of f of negative x.
Thank you.
In
Imaginary.
roots come in pairs a plus b and a minus bi.
Thank you, right? So again, imaginary roots come in pairs. So if you have, for example, a 2 plus 3i, then its conjugate 2 minus 3i is also a root. Are we good? Right? And in here, the number of roots is what? Depending on f of x and f of negative x, right? For example, we have the following in here, number 47. F of x is equal to x to the fourth minus, what's that? X squared minus 1, okay? The problem for number 47 is this, okay? Let me read it for you guys and see it from your instruction. Use Descartes' rule to determine the number of possible positive and negative roots, then graph to confirm which of these possibilities is the actual combination. Are we good? Right? So with that, what's this gonna be? How many positive roots are there? Possible positive roots, how many? Well, let's count, right? How many sign changes are there, right? So this is positive, right? From positive, it becomes negative, right? So one sign change. From negative, it's still gonna be negative in here, right? So that means no sign change at all, right? So how many positive roots are there? Just one, right? Okay. Are we good? Again, why one? From positive x fourth to negative x squared. So there's one sign change, right? Now from negative x squared to negative 1, it's still negative, right? So there's no sign change, right? So in short, there's one possible positive root. Maximum. That's the maximum positive root, right? Questions? Questions? Okay. Next, how do we get the negative roots? Well, we're gonna get f of negative x, right? So if we get f of negative x, let's see what's that gonna be. So the x in here will be what? Negative x to the fourth power. Okay. Minus this x in here will be negative x to the second power minus 1. Okay, so again, I'm just re-evaluating f of x at negative x, right? So do not forget the parentheses, guys, right? X, that's negative x to the fourth, minus this x becomes negative x to the second power. Good. Now, according to this one, if the roots are positive, or sorry, even, what's gonna happen to this? What's negative x fourth? Positive x fourth. There we go, right? Again, because it's even, right? Minus, okay, what about this? Negative x squared. Still even, right? So if it's even, is it negative x squared or positive x squared? Positive x squared still, right? Okay. Right. Minus 1. Well, this one has no x, so no worries about that one, right? Hence, this is your f of negative x, right? Good. Again, it just so turned out that your f of x and f of negative x are the same. You know why? Because they're all even powers, right? But again, if they're odd, you sign change. Get it? Now, what do we do? Just the same, right? Possible negative roots. So how many possible negative roots are in here? Do the same thing. This is positive to negative. So that's one sign change. We good? Negative in here, still negative there. That's 0 sign change. So what's the maximum number of negative roots in here? 1. Again, this is the maximum, right? Are we good, guys? Okay. Last one. If we have the positive roots and negative roots, one maximum positive and one maximum negative root, the question now is, how many imaginary roots can we consider for such, right? How many? Possible imaginary roots. Well, we can say in here either 0 or 2 possible imaginary roots. Are we good? Why? Why? Because if there's at least one imaginary root, right, then its complex conjugate is also a root, right? So it always comes in pairs, right? So it's either there's 2 or there's none. Are we good? Right? Now the question is, Mr. Deal, can there be 4? Actually, it can be a possibility as well, right? So we can put in here or 4 as well, right? Because again, it says in here that your possible positive root is 1 maximum, right? But there can be no possible positive root as well, right? Same in here for the negative root. There's a maximum of 1 negative root, maximum, right? So there can be 0 as well. Are we good or not? Get it? But again, your imaginary roots can be what? 0, 2, or 4, right? Why? Because this is degree 4 anyways, right? There can be all 4 imaginary roots as well. We good? Again, the Descartes rule of signs just gives us an idea on how many positive, negative, and imaginary roots there are. Are we good?